Hello and welcome to NARC Live on Wednesday the 22nd of March 2023. Coming to you live from Norfolk on the east coast of England with Tammy M0TC.
Hello.
And me, David G0KYA. Great to see you. On tonight's show, Steve G0KYA helping us to make sense of the numbers in space weather and the ionosphere. We find out about the new UK emergency alert service being tested across the country in a month's time. And we find out what on earth this is or was or is. Only had 3 entries this week, so great opportunity for you. If you think you know what that is or what it does, then pop it onto Facebook or BATC and we'll read it out when we get to the competition in a moment. But we start with some club news, and I'm not going to talk too much length of this, but if you got a strange looking email yesterday, probably the subject would have been new user details, but it didn't look like it came from NARC, although it might have mentioned something in NARC, and it had actually our webmaster G0LGJ's call sign in there. It was genuine, but rather unexpected, and I'm sorry it went out to quite a few people. I've had quite a few emails, people concerned that maybe our system had been hacked or anything. Actually, it hadn't been hacked, but we just didn't realise. Mark has been doing some maintenance, basically. He's our webmaster, and he's been doing some maintenance on our web system, the website, which also generates our newsletters. When you send out 300 odd newsletters, you can't just do it with an email. You have to do it with a proper system. And he was upgrading that system, and what he didn't realise, it was going to write to most people and say, give them some information about K-Hosting, which is the company that we use to host the website. But anyway, you don't need to know much about it. If you do get that email though, it's called New User Details. You don't need to write to me, but thank you to everybody who did and said they were concerned. But just delete it basically. And I'm sorry that we couldn't give you any advance notice. We just didn't know the system was going to do that when we did it. And another piece of news, not really club news, but news that will affect many of you, and we have run coaches trips and things before to the National Hamfest. But if you haven't already heard, the National Hamfest for 2023, which was organised for September, in fact to Peterborough, they would change the venue, but that venue then cancelled their booking, and we can't use the original booking or normal booking of Newark. So I'm afraid this year's National Hamfest is cancelled. Details are on the website and also on nationalhamfest.org.uk if you want to see why and a bit more detail about it. But of course it doesn't affect our own Barford Norfolk Amateur Radio Club Rally, which is on July the 2nd this year, Sunday July the 2nd. Now, this is the last NARC Live before our annual general meeting, and I know I've used the last 2 or 3 NARC Lives to mention various things and plug a few things, but it is really important to us that as many of you members of the Norfolk Amateur Radio Club come to the AGM and support it also by voting. And if you can't come to it, there's a few things you can do. So Tammy, if I could ask you to put the first slide up. So these are the things that we need you to do for our AGM before the 31st of March, which is next Friday, a week this Friday, okay? These are either before next Friday, or if you're going to want to do any of these things at the club meeting at CNS, that will be next Wednesday. So these are the things. We'd love to see as many people as possible enter things for the construction competition. As I've mentioned before, they don't have to be big projects. They can be simple projects, they can be commercial kits, or they can be your own designs, and they can be extravagant, big things if you like, because the competition is all about displaying your wares and things that members have made. And also the judge, which is last year's winner of the competition, will be looking for the quality of construction, not how big or complicated or clever it is. So please get your entries ready. That's for our AGM, which will be in person on the 5th of April. Also, we really want you to vote for your Speaker of the Year 2022. We get around about 100 people watch these NARC Lives, and last year we had 26 talks, and we've made it really, really easy to vote. But we've had a good number. We've had 46 people, I think, as of today, vote for this, but around about 100 people watch. So if you enjoyed any of our talks last year, please vote for your favourite by going to the link that's been in the newsletter and on the website. We may, if we have time, pop them onto BATC and Facebook again tonight, but they are within the newsletters and they are on our website, and then you can vote for them. Now we also, every year at our AGM, we elect the team of people that are going to run your club. And of course that often is a lot of same old faces, people like me who put their name down, but there's also new blood often and fresh blood as it should be. So if you would like to take a part in running me in the committee or an officer for the club, including my position as chairman, then your opportunity to do that really ends next Wednesday at CNS, where there's a file which you would put your name and then a proposer and a seconder, or if you want to, you can do it by email, but that needs to be done by the March the 31st, because there's then just a few days before the AGM. Another thing that you need to do before the end of the month is nominate which charity the club should support this year. Now, there are already 3 nominations for charities, but if you have a charity that you would like the club to consider supporting, and it will be a members' vote on the night at the end of the day at the AGM, then please send that email to me very quickly, and certainly before the 31st of March. This is so that we can prepare everything in the few days that are between the 31st of March and the 5th of April, ready for the AGM. And then finally, unfortunately, our treasurer, Mark G0KYA, can't be at the AGM this year. So he has asked, put a link on the website for accounts, and if you have any questions on those accounts, we'd ask you, if possible, to please ask them before the 31st of March. You will be able to ask them on the night, but I can't guarantee that I or any of my fellow officers and committee will be able to answer them, because our treasurer won't be there. So if you'd like an answer, if you'd like a question asked about the accounts, please do that before the end of the month. So I'm sorry that I've spent this time doing this yet again, but it's really important. If we can just have a look at the next slide, Tammy, and this just shows you what's happening on then. So the date for your diaries is Wednesday, the 5th of April. That's 2 weeks' time when we have the AGM. It's an in-person event. I'm afraid we won't be streaming that event. We want it to be an in-person event so that people can celebrate the awards and other things happening that night in person. That's what the committee decided, that we really wanted this an in-person event. There's a construction competition display from 7 o'clock till 7:45, when the judge, Mark G0KYA TMT, will also be going around and judging the entries. Then our AGM proper starts at 8 o'clock that night. You'll be able to elect. There may be need to have an election of the team to run your club if there are more people standing than there are positions. Also, the people there, the members there, will be able to vote on which charity the club should support this year. And there'll be lots of presentations of awards to people as well. So an enjoyable night. Please put it in your diary. We'd love to see as many members as we can at the AGM on the 5th of April. If you can't make it, I understand, and there will be minutes and photographs taken as well during this. You'll be able to read up about the event afterwards. Thanks for your patience on that. So this is the last NARC Live, as I said, before the AGM, so it was important to go through then. Now, at the top of the show, I mentioned something called the Emergency Alert Service. And this is something you may have heard about. It's hit the news in the last few days. It's not really amateur radio as such, but it uses some interesting technology, because basically the government have a system now where they can send an alert to people in various parts of the UK, or the whole UK, to their mobile phones and some tablets and mobile devices. And Tammy, I think we've got a slide that we can show now. This is just a kind of extract of what you can find on the government website. So it's gov.co.uk, and if you want to know more about it, it's going to happen, by the way, there's a test happening on Sunday the 23rd of April. There's lots and lots more information though on the full website. So if you're interested in this, make a note of UK Emergency Alert System, type it into your web browser, and you'll be linked to the government website, where you can download lots of information about it. But it is worth you reading it, if not least because otherwise you might get a rather nasty shock if you have a mobile phone or a mobile device on Sunday the 23rd of April, when it should start making a noise. But the technology to us as radio amateurs is also interesting, how they're doing that. You don't have to be logged in, as far as I understand, or anything like that. This is going to just happen on your mobile device. I thought you'd just be interested in it. Now, we love to see your pictures and hear your news and everything here. And it's not often, though, we're sent a video. But this week is an exception, because Steve G0KYA wrote to me a few days ago and said that I've just bought a fantastic soldering iron that I'd love to tell people about the club about. If I do a little video review of it, would you show it? And I said, yeah, of course. And so here it is. It's in two parts, and this is the first main review of this rather nice soldering iron.
Evening everybody, just let you know this little thing I found at Lidl's. It's a cordless soldering iron, 20 volts, and it uses one of these sort of batteries where you buy one battery to do everything with. This is a 2 amp 20 volt battery, 2 ampere hours that is, and when you buy it you get the charger and the battery for £25, and the soldering iron unit itself is about £13, £12.99. And to use it, you just fit the battery underneath the unit here, switch the switch on, and then it flashes. And once it's reached temperature, it goes green. So we'll just watch that for a second. It warms up very, very quickly. Good little unit actually, and fantastic if you need something out in the fields when you don't have mains to hand, or if you need something quickly, you don't want to carry a load of stuff around. This is quite simple. As I say, it heats up very, very quickly indeed. It's up to temperature now. And so let's get a bit of solder here, get the iron on, and as you can see, hopefully I get that in the right place. Very, very good. Nice iron. It comes with two bits, a chisel bit and the pointy bit which you see in there, and if I switch it off, it then flashes again to let you know that the iron is still hot. And yeah, nice bit of kit. Comes from Lidl's, and they've got them in stock at the moment in Norwich, so hopefully it will be useful to some of you who repair things and make things. Nice little unit.
Fantastic review, I thought. Firstly, Steve, thank you very much indeed for sending that, and if that's inspired any of you to do something similar, we would love to receive. We'll tell you how to get a big file like that to us as well. It's very easy to do, and we would love to see things like that. But anyway, that was a fantastic review of that soldering iron system. I'm sure you'll agree. Steve also added a very short video after that just to show it heating up a large area, because as radio amateurs, I'm sure there's many a time when you've tried to solder something to, say, a screening can, or maybe something big for an aerial, or big bit of wire, and if you've got a small 25 volt iron, that may not do the job. He's just sent this little short video to show what you can do with a can of beans maybe, or something like that. Have a look at this.
And the iron is pretty powerful as well. This is a unprepared tin can with a bit of solder on top, so if I just melt this solder, you'll see that it will actually, there we go, that's actually stuck to that. That's a big old setup, but there you go. What about that? I mean, that is pretty good for a soldering iron of that price. Really good.
Fantastic. Well, not for me to add anything to that review, except how long is Lidl's going to be open for? Another 15 minutes or something like that?
No, they're open till 10, aren't they?
Oh, are they? I
think
don't
so.
know. We're not here to advertise them. But anyway, a really good review, a really good looking product for an amazing value, especially if you want to do stuff outside, as often these sort of aerials and things as. But anyway, most importantly, thank you very much to Steve G0KYA for sending us that video. As I said, if you'd like to send us anything like that in the future as well, we're more than happy to receive it here for NARC Live. That's what it's all about. After all that, Tammy, it's over to you for Little People, which I haven't seen this week.
No, okay. It's just for you this week, the Little People. Here we go. Now the train one. We haven't had a train one for a while.
We haven't. Oh, I love that.
So it's all the salt and pepper mills. Now I know why we have so many salt and pepper mills at home.
Yes.
Because you've been playing trains with
no,
them.
no, not me. That's brilliant. Isn't that brilliant? You have to sort of look and then think, oh yeah, that's a salt and pepper mill. Brilliant. Miniature-calendar.com. As you know, they put a new picture up every day. Tammy picks one for us. Thank you very much. So, as you've seen Steve's review, we haven't had much other news and things from you, pictures which we would love to see, and you can always send them to us to this address. Sorry, Tammy, if I'm going to put you out here. It's radio@dcpmicro.com. You're most welcome to send us anything at all for the programme, and we'll put it on the next time. We don't meet actually now for 3 weeks, but generally we meet every other Wednesday here online. Please keep in touch with us. Now round to that competition which we set 2 Wednesdays ago, when we asked you, what on earth is this? Now, I know it wasn't the clearest of pictures, but we're very grateful to the person who sent it. It's actually Dave G0KYA, I can tell you now, who sent us this picture. Probably not an easy thing to photograph, actually. And before we read the people who emailed us, Tammy, we had some people online, I think, have suggested.
We have, yep. Tony M0TDK says he thinks it could be the weight from a pressure cooker.
Oh, yeah. One of those things you stick on the top to stop it going bang.
Exploding.
Yep. Okay.
Hang on, where are we? Steve G3EVA says, is it a fluorescent lamp starter?
Yeah, I can see that. Yeah, okay. David Stansfield says, is it a vintage camping coffee percolator? And Andy M0NKR says, few guesses for what it is. Is it a bottle top, gear stick knob, or a grinder cutter of some sort? Very difficult as the picture's not very clear. Yeah, it is a bit difficult. You're sort of maybe close on one of those, Andy, but I can't say any more than that, because let's now go to the people who've entered us, who've written to us online. And Nick 2E0IBP says, I was way out with my last guess, but I'll have another wild stab and say it's some kind of shielding can.
Tom G8XQD says, this has totally flummoxed me till I realised this is a rechargeable battery for a portable sewing machine.
No, I think it's fair to say we're not sewing machines. Stuart G0KYA says, to answer the what on earth is this question from last Wednesday, the 8th of March, you'll need a lot of bottle. Unfortunately, not understanding its use may leave you pale or even bitter. It may ail you so much that you will need a porter to move you, to change your attitude from sour to mild, maybe even creating a stout personality. It will certainly help if you are a mixer with a fruitful outlook, as long as you don't think I'm taking the juice or fizz out of it. What is it? He says it's an automatic crown-capped bottle opener with a trade name of Zap Cap. And also Stuart says, bet you're glad I don't answer the question, what on earth question too often. Well, we haven't got a long enough show, but anything else. Thank you for that entry. Anyway, Tammy, please reveal what it is.
It is.
It is the bottle opener. Never seen anything like that.
I don't quite know if there's a button or anything on it, or if you just push it down and then pull it up, I guess, probably.
Maybe a video.
Yeah.
Could be said to us. But anyway, that's what it is apparently, and only one person guessed. But thank you very much for sending us that to Dave G3VSJ. Oh, and by the way, yes, we've had a message from Paul Gunther, who we actually saw, by the way, at the school the other day, G4XBT. He lives in Poland, was a member years and years ago, and he came to see us at the club. He says, here in Poland, we've had the emergency alert system for over 2 years. It works very well. It gives an early warning for winds, rain, etc. So anyway, find out more information on the website. Lovely to hear from you, and it was very nice to meet you as well, Paul, a week ago. Anyway, let's now go round to our question for our competition for this week. What on earth is this? It's one of those things, it's easy if you know it, isn't it?
Yeah.
I better not give you any clues. I get told off if I do.
Yep.
So send your answers to radio@dcpmicro.com. You've got a full 3 weeks to do this, but
do it now.
Yeah, or you'll forget, like I would. Do you know what that is? It might be one of those things that's a straightforward object, but from an unusual angle, do you think? Is that fair to say that? Okay, have a think. Let us know. So before we meet tonight's guest, let's just talk about what's happening at the club this week. We have on Sunday at 7 o'clock the GB Tourist News on GB3MB. On Monday at 7:30 the Monday Night Net on GB3MB, and then at 8 o'clock the 80 metre CW Net on 3.543 megahertz. And then next Wednesday, the 29th of March, it's a meeting at CNS between 7 and 9:30. It is a social, plus it's the first main sessions of both our NARC Raspberry Pi Jam, which starts at 8 PM, and we also ask you to bring your Pi systems and start setting them up from 7 o'clock so that we're ready to go into our first main session at 8 o'clock. And then just before that, the NARC Maker Construction Group. You remember we started this a while ago? They're going to be making an amplifier for a magnetic loop, and that starts at 7:45. So that's happening next Wednesday, the 29th of March. I'm afraid the numbers for the Raspberry Pi Jam are such that there's 18 people and we can't take any more on that. However, we have still got a couple of spaces on the NARC Maker construction group. So if you're interested in making, just making something basically, but if you're particularly, the first project is going to be a magnetic loop amplifier, then you can join us next Wednesday night from 7:45. And also very important to tell them that we went shopping, because we really ran out of drinks last time, didn't we? We went shopping to a wholesaler, and as well as the usual drinks there, we also bought a crate of shandy. I think you'd have to have a lot of it to feel, shall we say, happy. But anyway, there's an extra, as well as the cola and orangeade there. There's some and ginger beer, of course. There's some shandy there as well. Really important news, that, isn't it?
That is.
Just to tell you as well, then, just one more final plug, that the Wednesday after next, which is the 5th of April, is our AGM. We hope to see as many people there as we can. And of course, we love to hear your stories, your pictures, and your videos as well, indeed. And also, of course, our Norfolk Amateur Radio Club card. And we have a sympathy card, and we have just a get well and a happy card to send people as well, which we're happy to send to anybody who you just send us a name and address to, and hopefully it cheers them. Now we're on to our main event, and our guest tonight will be no stranger to members of Norfolk Amateur Radio Club at all, indeed to many people in the radio community. It's Steve G0KYA, and he's here to tell us what the numbers mean with space, weather and ionosphere, and we're going to say hello to you now, Steve. Hello.
Hello, how are you?
I'm good. How are you doing?
Not too bad, not too bad.
Good. Before you start, Stephen, I know you're going to tell us all of this. You're doing the presentation tonight. I thought we talk about space weather and we hear about it in things like propagation, but what does it actually define? And I looked at it online, and this is what it defines. It says it's the conditions in the region of space close to the Earth, especially the presence of electromagnetic radiation and charged particles emitted by the sun, that can affect human activity and technology. So I thought that was fairly sort of heavy stuff to read, and you're going to help now tell us what we can make of the numbers and things that you give with your propagation forecast, I believe.
Well, yes, I mean, we use a lot of terms every week with GB2RS, the propagation forecast, and I sometimes think, do people actually understand these? So this is really almost for beginners. I've gone over some of these things before, but we're going to have a look at a number of bits and pieces. In fact, let's advance the slide. So we're going to look at the solar flux index and smooth sunspot numbers, K, KP, A and AP indices, the solar wind, the speed, and also something called the BZ. What is it and why is it important? Then critical frequency and maximum usable frequencies and solar flares. And we'll start off by just having a quick look at the solar cycle 25 progression, see where we're going and how it's going. So hopefully this, if everyone's still awake when we finish, then I'll take questions. But
I was going to say that, Steve, if you don't mind me just mentioning, as always with this, in case this is the first one you've seen, you can ask questions and make comments about Steve's talk at any time during the presentation, either on BATC or Facebook, and we'll read them to Steve at the end of the presentation. But anyway, back to you, Steve. We look forward to making. I'm one of those people. You said this for beginners. I'm certainly one of those people who listens to the propagation forecast every week on RSGB, and I don't know what all the numbers mean and MUFs and things. So we look forward to tonight's talk.
Yeah. Okay. Well, let's move on then. I mean, just before we start, that picture on the right of the aurora, I took that in Iceland. And if anyone wants to go to Iceland to look at the aurora, have a chat with me, because I'll tell you the pros and cons. I did speak to somebody the other day, said, oh, they wanted to go to Iceland in June to see the aurora. So you'll be very lucky, to be honest. But, well, you won't, because it's too light. But that's an aside anyway. OK, so let's have a start then. Where are we in solar cycle 25? Well, I downloaded this morning. So this is where we are. And you can just see the prediction, the green line is prediction of where it's going. And basically, we're kind of going along with what we had last year, solar cycle 24. At the moment, anyway, it's looking okay. It's not bad, but I think at one point there were talks of it being a phenomenal cycle. Maybe not. We'll have to see. It's way too early to say yet, but that's where we are anyway. Sunspot number of about 150, I think it's been about maximum 160. But we'll just have to see how it goes. It's a good time to be on HF anyway, which is important. Okay, so let's have a look. Let's talk about the solar flux index first of all. We'll talk about what it is. But I thought before we did that, I'll just show you where I get the details from for GB2RS. There's the URLs at the bottom. And this gives you, I think there's about a month's worth of figures, the solar flux index and sunspot number. And these are updated every day. And there's another one for the geomagnetic indices as well. And that's the easiest way to get historical information from the official Space Weather Prediction Center at NOAA in the US. There is actually a space weather division of the Met Office now. And I remember writing a story about this a few years ago, and it's quite well established. But I mean, I spoke to them recently and said, look, could we have some details of what you can offer? And they only predict forward 4 days. And I said, no, that's not enough. I need more like 10 to 14. But it is worth having a look at their website. If you go to Met Office and then search for space weather, you'll find information along these lines anyway. But that's where you can get information on solar flux index and A index, K index, and solar flare information. And it's a very, very, very simple download, and it's completely free, of course. But exactly what is the solar flux index? Well, this is the sun as of this morning. And you can see we've got some nice sunspot groups there. And the numbers we really need to know is that we have a sunspot number of 70 and a solar flux index of 152. So what do they mean? What is this information that they give us? Well, the solar flux index is the strength of the radio signals coming off the sun at a wavelength of 10.7 centimeters. This may sound a bit odd, but this is a proxy, if you like, for the amount of radiation coming off the sun. And it's been in use for a long time now, before the second, I think just about the Second World War. Why do we measure it at 10.7 centimeters? Well, it was found as a kind of a correlation between that and the strength of the ultraviolet light coming off the sun. We can't measure the extreme ultraviolet and ultraviolet light coming off the sun on the ground because it gets absorbed by the ozone layer. But the 10.7 centimeter figures are, as I said, a proxy for the extreme ultraviolet and ultraviolet coming off the sun. And so the numbers, what do we mean? Well, they never go lower than about 65, I think about 65, 66, and can go as high as 300 and odd. So that's the kind of range we're looking at. I think today was about 130 odd. And for giving an example, for 10 meters to open up to F2 layer propagation, we really need a number in excess of 100, which we've been getting for some time now. And this is why the 10-meter band is being wide open. A couple of months ago, it was open very well daily to the States. It's not so good for the States now, but it's good for South Africa and South America. But there we go. So in fact, the solar flux index, high values generally indicate there is sufficient ionization to support long-distance communication at higher than normal frequencies. So we had years of numbers down in the 60s. I mean, it's sunspot minimum. We're now at 130 or thereabouts. And could it go as high as up to 300 maybe? Well, we'll just have to wait and see. But that's what it is anyway. And it's the strength of the radio signals off the sun at a wavelength of 10.7 centimeters, which is a proxy for the amount of ultraviolet radiation coming off the sun. And an alternative way of looking at it is to look at sunspot numbers. We sometimes talk about sunspot numbers. But people think that if they hear us that we've got a sunspot number of 90, that means there's 90 sunspots, but it doesn't. In fact, we score 10 points for each sunspot group and 1 for each sunspot. So if you have one sunspot in one group, that would be a sunspot number of 11. And if you had 3 sunspots that were well separated, then that would be 10 plus 10 plus 10 plus 1 plus 1 plus 1, i.e. 33. So you can see there, if you've just got 3 sunspots, you could easily get a sunspot number of 33. And the lowest value you can get is obviously 0, which we've had before now. And the highest you can get is 286, and that was in solar cycle 19, 1954 to 64, which is one of the better cycles of the time. So they're the 2 methods of really measuring how much ultraviolet light is coming off the sun. And these methods have been used for quite some time, so that we can go back in history and look at what sunspot numbers were recorded. So it's a way of recording it historically. People say to me, well, why don't you just measure the ultraviolet intensity with a satellite? Well, yes, you could do that, but we just needed a way of doing it that could be used around the world at ground level and could be compared with other figures from years gone by, and that's the way we've done it. And what's the relationship between sunspot number and solar flux index? Well, yes, it's not quite a relationship, as you can see, not a hard and fast relationship. This scatter diagram is a measure of the sunspot number over a period of time versus the solar flux index. And you can see that it's scattered because not always, you know, a solar flux index of 250 doesn't always indicate a sunspot number of 300. But we can use this as a rough guide if we want to convert between the two. So as I said on the right there, a sunspot number of, I think it says 135 is roughly equal to an SFI, or solar flux index, of 150. But you'll see that some programs and some articles you read talk about sunspot number, others talk about solar flux index, but that's where the two come from. I prefer always to talk about solar flux index because I think the sunspot number can be confusing, because you can go from a sunspot number of 0 to 11 and it sounds, oh, we've had a massive increase, but it's actually one sunspot. So I think it's much easier to talk about an SFI, solar flux index figure, and it's easy to work out roughly what you can do with it. So what difference does it make? Well, this is a VOCAP diagram of the circuit reliability or the maximum usable frequency between the UK and New York in October for sunspot numbers of smooth sunspot numbers of 10 and 115. And you can see on the left there, the maximum usable frequency around about 3-4 o'clock in the afternoon was roughly 20 megahertz. So, okay, so 20 meters, 14 megs would be open, 17 probably open. But now look at the one on the right with a smooth sunspot number of 115. It's over 30 megahertz, easily over 30 megahertz. And so that's the difference. You know, we do need sunspots, and because this extra ionization energy coming off the sun, you know, works wonders for the ionosphere and actually makes it far, far more reflective or refractive, if you like. And so the maximum usable frequencies between those 2 points go up dramatically. Now, where's your first stop on the internet if you want to find out more about all these sorts of things? I always recommend solarham.net. It's run by a Canadian amateur, V3EN, and it's got everything you need in one spot, in one place. So you've got solar flux index, you've got K index, A index, which we'll come on to later. You've got details of flares, X-ray flares, you've got a magnetogram, you've got coronal holes, we'll talk about those later as well, and everything you could need in one place. So it's a nice one-stop shop, really, for solarham.net. And he does this off his own bat as a freebie. He does ask for contributions every now and again, but I think he's got enough money for next year. So there we go. It's a nice site anyway, and it's worth going and having a look anyway. So that's solarham.net if you want to make a note of it. So we've talked about the ionizing nature of the sun, but there are also matter coming off the sun, plasma, if you like. So the sun is constantly losing this plasma out into the space, and it's called the solar wind. And at times this wind can be very ferocious. in terms of both its intensity, density, and speed. For example, you can have a solar wind, an average solar wind is about 500, 450, 500 kilometers per second, not per hour, per second. That's how fast it is. And this density can increase dramatically. And the solar wind has nasty effects. Satellites don't like the solar wind. It causes charging on them, which can cause single event upsets, so the computers have to be reset, or it can slowly destroy the solar panels on satellites, actually. And so this plasma that comes off the sun is usually caused by coronal holes or coronal mass ejections, the massive amounts of plasma that come off the sun. And we'll have a look at those in a minute. And this solar wind also has a frozen-in magnetic field. It's a characteristic of plasmas that if they come off the sun, if it comes off the sun with a magnetic field frozen into it, it kind of stays there. And if that field, we call that the BZ, that's B as in magnetic field and Z as in the direction of travel. So if you think of X and Y being up and down, the Z direction is straight at us. So this Z direction of the B field, or the BZ as it's called, if that field, the solar wind field, if you like, is pointing south, it more easily couples with the Earth. It's just like magnets. If you think of the Earth as a north and south magnetic pole, well, if the interplanetary magnetic field coming off the sun has its field pointing south, then just as north and south magnets will attract each other, then this stuff gets channeled more towards the Earth. And when that happens, it disrupts the ionosphere and distorts the Earth's magnetic field. It can also trigger aurora, and we'll have a look at how we measure that shortly. But I just sometimes wonder if it's worth just explaining what this BZ is. It's the magnetic field of the solar wind. And we take the BZ component, so that's the Z component of the B field that's coming towards us. And if it's pointing south, that's not good news. So it's important to know, basically, if the BZ is pointing north, it has very little effect on the Earth at all, and you don't get much of a disturbance. But pointing it south, yes, that's when you get big trouble. So this is the sun this morning, in visible light on the left and in extreme ultraviolet on the right, taken with the Solar Dynamics Observatory. And you'll notice that on the left, we can see some sunspots that are moving around. They rotate from left to right. So it's going to get a bit busier, I think, over the next 7 days. But if you look on the one on the right, this darker area is called a coronal hole. And these were discovered really in the 70s, I think, when Skylab was out. This was the first time they managed to put an X-ray camera or extreme ultraviolet camera in space. And they were surprised when they pointed at the sun to see there was these black holes, or apparently black holes. And these are areas on the sun of lower intensity, which is why they appear black. But they're areas with open magnetic field lines. So the trouble with open magnetic field lines, it just allows the plasma to flow out. So we really don't want to have a coronal hole pointing towards us, and that can cause big problems. This one, if you notice, it's mostly in the southern hemisphere, but there is an arm that comes up and is going towards the equator. So we know that from this, I would say in about 2 days' time, I wouldn't be surprised if the K index goes up. We'll talk about that shortly, but as a result of this coronal hole. And once the K index goes up, we get a lowering of the maximum usable frequencies and the lowering of the ionosphere, or the density of the ionosphere. So it's not good news. So coronal holes are very important, but I think they're misunderstood an awful lot. So if that coronal hole had been in on the sun's equator, pointing straight at us, we'd have really big problems. I think we'd see the K index hit 4 or 5 probably. As it is, it's lower. You've got to remember this is a sphere we're looking at, so it's on the bottom of the sphere. But I think that arm that's coming up there towards the center is going to cause issues with us anyway. But that's basically what a coronal hole is, and they were discovered really by Skylab, and play an important part in in space weather. So this is an example of what does a coronal hole do. Well, you'll see that the coronal hole there marked as 34, and the direction of rotation is left to right. So that's probably about a day and a half, 2 days from being right on looking at the Earth. And you can see that it caused a KP index of 5 there, and then tailed off to 4, and was still at 4, a couple of days later. So that's the kind of effect we tend to see. So you can kind of predict what's going to happen with the sun just by looking at the coronal holes, and they're not quite so prevalent as they were. But as I said, if we look at that one from this morning, that's a massive coronal hole, and it would not be good for the ionosphere at all. So we'll have to see what happens in 2 days. So let's have a look. It's now Wednesday. Yeah, I would say looking at Saturday morning maybe the time to expect bad ionospheric conditions. But we'll soon know, because the K index will go up. But there we go. So how long does it take this solar wind or material from a coronal mass ejection to hit the Earth? We'll have a look at a CME shortly, but well, if you do some sums on this, that the Earth from the Sun is 149.6 million kilometers on average, and the speed of a CME or solar wind is 400 to 800 kilometers per second. That leaves us at about 2.1 to 4.3 days. So that's the time from when the coronal hole becomes Earth-centric to when it's going to actually hit the Earth. So this is the first problem we get with space weather, in that, okay, so there's a coronal hole, but we don't know what the BZ will be. We don't know what direction the magnetic field will be for any plasma coming off that coronal hole. So we can't say for certain, yes, that will be a disruptive event. CMEs are the same, coronal mass ejections. We don't know what the interplanetary magnetic field is going to be. So we don't know the speed. It could be a really fast one. There was a very, very fast CME the other day. It was up to 3,000 kilometers an hour, I think. Actually, 3,000 kilometers per second, I beg your pardon. So we don't really know exactly how long it's going to take us to hit the Earth. And we don't know its characteristics. So it's a little bit of a guessing game. It's getting better, but we obviously, these things hit satellites before they hit us. So if we know that we probably get about 2 hours warning if one of these hits one of the satellites that's out there. But when I do the calculations for coronal holes, I average it about 2 days. So if there's a coronal hole center of the sun right on the equator, then 2 days later you're likely to get the KP index go up. Now this is leads me on to solar flares and coronal mass ejections. I use the two terms together. You can have a solar flare without a CME. And can you have a CME without a solar flare? Less likely, but it can happen. But what I wanted to have a look at in this is, if you see the Earth to scale down the bottom there, that tiny little dot, just look how big these things are. If a coronal mass ejection is a massive expulsion of plasma off the sun, and it is massive. I mean, it would literally just, if we were a lot closer, it could wipe out the Earth completely. But so this is what we're dealing with. They are massive, billions of tons of plasma traveling at hundreds of thousands of miles per second. So should we be worried? Well, probably not. I mean, we've had coronal mass ejections hitting us for 2,000 odd years. They don't do too much damage, but they do cause aurora, and they can cause problems to satellites. There have been satellites that have been destroyed by CMEs. And back in the late 1800s, there was the Carrington event, which was a massive solar flare stroke CME, and that caused no end of problems with electrical, I think it was telegraph more than anything, where people were getting electric shocks off telegraph equipment, and the Morse readers or Morse tappers were going completely nuts. It's an issue, and it is one of the this country's big events that could happen, and it appears on the government's documents in terms of risk factors, I think, a massive CME. And if anyone has seen, I think, I'm trying to remember what the name of the film was. There was a film where a CME hit the Earth and basically destroyed it. It wiped the Earth's atmosphere off the Earth and destroyed it. Not a good thing to watch, really, but I think it's obviously science fiction, but it does make you wonder. We have had massive CMEs hit, and usually it appears in the paper as a good day for Aurora. But we'll see as it goes on whether we're going to get more of these or not. So that's solar flares and CMEs. A solar flare is a massive explosion of energy, bit like winding a rubber band up and then the band breaks. That's what actually happens. You've got the magnetic fields on the sun which are rotating, and they get twisted up. And eventually the whole damn thing gives up and emits a solar flare. And let's see if we got this one here. There's a picture of a solar flare that's going to come off the watch sort of the bottom right of this image. And you'll see in a minute there'll be a coronal mass ejection come off the sun. There we go. So it's a massive explosion that comes off the sun. Now, the main component of these solar flares is a massive surge of X-rays and extreme ultraviolet. So we can measure that extreme ultraviolet and X-rays with satellites, so we know how much energy is being released. Now, I did some sums just for the sheer hell of it, and the energy released from an X-ray solar flare can exceed 10 to the 20 joules of energy. So for comparison, the atom bomb that was dropped on Hiroshima was 10 to the 13 joules, and the world's biggest hydrogen bomb was 10 to the 17 joules. So we're talking about an explosion, an average explosion, which is at least 10 to the 3, so 1,000 times greater, or 10 to the 25. So what's that? That's 5. That's 10 to the 8. So 100 million times stronger than the biggest hydrogen bomb ever released or set off on the Earth. So it is a concern. These things are massive. When we get a solar flare, we get something called a SID, or sudden ionospheric disturbance, as well. And that's because this ultraviolet and X-ray photons traveling at the speed of light, obviously. So it happens 8.3 minutes after a solar flare, and it can just basically, they impact the D region of the ionosphere. So it stops radio waves getting up to the F layer. So basically it's like somebody turning the radio channel off. You'd be listening to somebody in America 1 minute, and the next minute they're gone. And these then usually kind of comes back to life in about 30 minutes, maybe 60 minutes. And the lower frequencies are affected more. So you may not see much effect maybe at 10 meters, 28 megahertz, but certainly down at 7 megs, 10 megs, 14 megs, you will see if you get an SID, that's it. It's kind of game over. We've noticed this when we do the Case de Marconi station every year, because we're there all day. You notice things, and if the K index goes up because of a flare or CME, conditions get really bad, and you're just struggling to work around the UK or close into Europe until things recover again. So that's a sudden ionospheric disturbance, or a blackout. And that's basically the ultraviolet and X-ray photons impacting the Earth in 8.5, 9 minutes after they leave the sun. But not only do we get ultraviolet X-ray photons, you're getting mass being thrown off as well. You're getting plasma being thrown off the sun as well. And the other types of events you can get a polar cap absorption event, which is high energy protons and alpha particles, which can impact the polar regions. And we'll explain why the polar regions are so damaging, or why it's so effective in the polar regions. And that can take 15 minutes to several hours, depending on how fast these particles are moving. And that can last 1 to 2 days. I like it there. So sometimes several years. I don't think I've ever come across a polar cap absorption event that's lasted several years, but that's what it says, so we'll put it down. And then obviously with a CME, you've got low energy protons, electrons, a soup of protons and electrons that are traveling out. We've talked about CMEs and coronal holes as well, massive amounts of plasma coming off coronal holes. And that takes about 20 to 40 hours to arrive, maybe 2 to 5 days. And basically, we get an increase in D-layer absorption and a depression of the maximum usable frequency. It affects the F2 layer. So critical frequencies go down, maximum usable frequencies go down, and that can last a couple of days as well. But we get aurora and sporadic E events as well as a result of that. I'm not so sure about the sporadic E events. I think maybe the odd case where we get an ionospheric storm and it results in sporadic E, but that's not the main cause of sporadic E. If Jim is watching this, he'll be shouting up and banging his table, I think. We'll have to talk about sporadic E another time, but it's not the main contributor factor to sporadic E. But ionospheric storms, we've had lots of ionospheric, can't even say it, ionospheric storms recently. And typically the maximum usable frequency goes down, D-layer absorption goes up, and conditions are generally bad. So that's what happens after we have material coming out from a coronal hole or a coronal mass ejection. So there we go. So you've got an SID, which is ultraviolet and X-ray photons, 8.3 minutes later, or over several hours, or maybe 20 to 40 hours later, you've got energy in terms of plasma coming off the sun, the low energy protons, electrons, causing increasing D-layer absorption and depression of the F2 MUF as well. So this is a scale of how bad things can be. So in terms of radio blackouts and X-ray flare, you'll see there that they're rated as M class or X class flare. We've had an X class flare recently, and basically an X class flare is probably as bad as it gets. You could have I think we've had an X7 recently, just the one, not many, but it is a massive radio blackout if you get an X20. So we will get these over the next 2 years. Absolutely, we will get something which we'll get more X-class flares. They kind of go with the territory. Or you can get a proton storm, which is the material that's coming out, plasma material that's coming off the sun as well. And they're measured in particle flux units. And I get an alert when these particle flux units exceed 1,000. I get these quite regularly every other day. These are the ones that cause satellite owners to get worried because it causes charging on the satellite. Not good at all. And then obviously the geomagnetic storms, which are caused by the plasma off the sun, they're measured in terms of G1, 2, 3, 1 to 5. And that relates to a KP index. There's another term we're bringing in here, the KP index. So a moderate one is KP equal to 5. And an absolutely rotten, serious, extreme one is KP equals 9. So you can see that there's a lot to take in here. But I think the thing is that what you've got to bear in mind, radio blackouts occur virtually instantly within a few minutes of a flare. Then 2 days later, we're going to get a geomagnetic storm, probably get a geomagnetic storm if the material is with a BZ pointing south. But these are the numbers you need to look at, the KP index, you see. And that's a measure of how disturbed the Earth's magnetic field is by this incoming plasma. And we'll look at that soon. So once we go to solarham.com, you'll see, or solarham.net, you'll see that there's the X-ray flux from the GOES satellite there. And you'll see these spikes. And these are solar flares. And you can see we've got an X2 solar flare there, an M5 and an X6. I said, I think we had an X7 recently, which is about as bad as it gets. But you'll see they tail off quite quickly. And yes, you do get this sudden ionospheric disturbance we have in a solar flare. They don't last too long, but you've really got to be listening all day to see the effects of one of these. So if you turn on your radio and you can't hear anything, it's a fairly good chance it was probably a solar flare that did it. But and if you want to check, you can go to solarham.net and have a look at the solar flare index and see what's happened. And it updates quite quickly, so you can see we really only worry about M-class and X-class solar flares. They're the ones that do the damage. There's lots of C-class flares, but they're not so important. It's a funny way of looking at it. So it goes A, B, C, M, and X, which seems silly, but that's the way we measure them. So X-class are the worst. M-class flares are slightly less damaging than X-class, but it's X-class are the ones that cause the problems. And this is what it does. This is the thing to point out is that an X-class solar flare has an effect on the ionosphere within 9 minutes. And as you can see from that chart, the maximum absorption goes up to about 10 megahertz. You probably won't notice much effect much above that, maybe kind of a 5 dB reduction of maybe 20 meters. And by the time you get up to 30 megs, 28 megs, 10 meters, it has little effect. But it's certainly do. And the thing is that it's always on the daylight side of the Earth. So if you have a solar flare at nighttime, it's going to affect the other half of the world. You can see the effect there that you would get. So it's degraded effects there over, what have we got? Oh, we've got over Europe and South America and North America there, up to about 35 megahertz, but not so bad at 30 megahertz, 35 megahertz, but certainly down towards the 10 megahertz, 7 megahertz, you're going to get problems with it. And again, you can get this graph appears on solarham.net as well. So as I said, flares only affect the daylight side of the Earth. And if they are visible on the sun's surface, if you can physically see the flare take place, it will impact the Earth. Whereas a CME tends to only affect us if it's fired directly at Earth. That is, a CME that comes off the edge of the sun may miss us completely, but a solar flare will hit us. If you can see it, it's too late then. The photons are on their way, and we're going to get problems. Lower bands are the most affected, as I said, and 28 megs may be unaffected at all. And if you look at this chart on the bottom here, you can see that 5 megahertz there was affected for an hour, 18 megahertz was affected for about maybe half an hour, and 20 megahertz there was a slight dip in signal strength, but nothing much. Again, this is solar flares, so that's it. If you turn the radio on and there's nothing there, it could possibly have been a solar flare. So we measured how this material coming off the sun, these charged particles, are impacting the Earth's magnetic field. And we measure that by using magnetometers and how far is the Earth's magnetic field being disturbed, if you like. And we call that the K index, KP index. We take K index measurements from around the world, and then we average them out to give a planetary index, and that's why it's called KP. So it's the planetary K index. And this shows you the sort of effect you can get. This was a chart from 2003. And you can see that the KP index was 9, and it went on for 2.5 days or so, so not good at all. That would have been a fantastic time for aurora, watching the aurora, but not good for radio, unfortunately. So there we go. So if you want to know when is it going to be possible to view aurora from the UK, then keep an eye on the KP index, and if it hits 9, you'll probably definitely see the aurora from Norfolk. But usually, if it's got to get above about 6 or 7 before you can see it from Norfolk. And when you see these fantastic photographs, don't be led by them, because normally they're long time exposures, and you'll struggle to see it, more of a faint fuzziness really in the night sky. To get the colors and the definition that you see in these fantastic photographs, that's usually time exposures of maybe 15 seconds or so. But yeah, K index of 9, definitely go and have a look at the North Norfolk coast. I think you will definitely see something. So just to recap then, so this is the K index. Quiet conditions are sort of 0 to 2. normal conditions beyond that, sort of 3 to 4. Now you're starting to get some problems. 5 or 6 is described as stormy, and 7, 8, and 9 greatly disturbed. So you very rarely see the K index at 0, especially at this point in the sunspot cycle. But you probably see it maybe 3s and 4s. Not too bad, but it's having an effect. And if it goes much beyond that, we get stormy conditions and things aren't going well at all. Now, there's another way of measuring it. Not only do we have the K index, we have the A index as well. And the same thing happens again. It's a measure of the disturbance to the Earth's magnetic field. Now, the K index is a logarithmic scale, so it only goes 1 to 9. The A index is not logarithmic and goes from 0 to 400. So you think, well, why not use the A index? Well, for the simple reason the A index is only updated every 24 hours, where the K index is updated every 3 hours. So if you're looking at space weather and you see, oh, well, we've got an A index of 100, that would be very severe. But it's quite possible to get a K index of, say, 7 or 8, but the A index is still about 15 or so because it hasn't been updated and won't be updated until the end of the day. So I generally don't use the A index because it's misleading, I think, to have it updated every 24 hours. So although the K index is logarithmic and goes from 0 to 9, I generally use the K index in all the reports because it's more up to date and you can keep a closer eye on it every 3 hours. And they've changed the K index recently to include decimal points. So now you've got a measure of the K index in tenths as well, or decimal points, so 0.1, 0.2, 0.3. So it used to be just a case of where it's 4 or 5. Now they'll say it is 3.8 or 4.5. That was changed about a year ago, and that's quite useful as well. So that's the difference. The A index is updated every 24 hours and is non-logarithmic. The K index is updated every 3 hours and is logarithmic. So don't get the two confused, but I prefer looking at the K index because you can actually see it change almost, well, not in real time, but every 3 hours you'll see it change. So as I said, a high K index or KP index, planetary index, means a lowering of the maximum usable frequency and generally bad conditions. You can get a situation that just as the K index is rising, you get what we call a pre-auroral enhancement with an increased MUF. And they're very hard to predict. I was going to do some work on this at one stage, but it is very hard to, you'd have to be monitoring things every day and, might have to monitor for a couple of months to see one event. But you can get a pre-auroral enhancement just as the K index is rising, but they are hard to predict. Now, the solar wind speed can also vary dramatically, but it's typically in the range of 400 to 600 kilometers per second, as I said. So it's fast. It is very fast. And solarham.com has got details of the solar wind speed and the K index, as I said. This is another feature that appears on solarham.net. This is a coronal mass ejection prediction, and it's an animated thing that if you imagine looking down on a garden sprinkler, one of those things that spins round, it's a bit like that. So you can see there that we're looking down on the sun and the Earth here. So you can see that we've got a spiral pattern, just like a garden sprinkler. And so this prediction is a NASA prediction, Space Weather Prediction Center prediction. And it was a prediction of how it's going to hit the Earth and when it's going to hit the Earth as well. And it's not bad. It's pretty accurate. And we've also got a satellite stereo. There were 2 satellites, so stereo ahead and stereo behind. So one of them broke some years ago. So we've only got the one now. We've got the stereo ahead one. So we have a little look around the sun at what's coming around at us. So it's better than nothing, but it's not perfect. And there are plans to replace these satellites with better, more up-to-date instrumentation. So we'll see how that goes over the next few years. Right, so let's just have a look at this CME prediction, just how it works. Just wait for the thing to. There we go. Right, so there's a CME coming off the sun. There's one just came off then. And I think this has. There we go. And that's what you see. If you go to solarham.net, that's what you see. So that's the kind of effect that you get. And so it shows you Earth is the little blue dot, and that shows you when it hits the Earth. So when is it likely to hit the Earth, and how bad is it going to be? Good. We'll move on from that one now. So where do we get this information from? Now, this is where it gets a bit tricky. So there is an outlook on what the solar flux index is going to be, and what the likely planetary K index is going to be. There's two ways of looking at it. You can go to the NOAA figures, the Space Weather Prediction Center NOAA figures, and they do a 27-day outlook that looks at the solar flux and geomagnetic indices. The United States Air Force do a separate one, which is a 10.7 centimeter solar flux index forecast, and also forecast of the AP index for 45 days as well. These two are sometimes different. And what I would say is that I don't think at the moment the NOAA prediction for the 10.7 centimeter solar flux index is actually that accurate, to be honest. It's a real problem because when I do the GB2RS, it's really written on Thursdays and goes out on Fridays. And then sometimes you're hearing it read on Sunday. So trying to predict what the sun's going to do using these figures is not very easy at all, and it's not very accurate. So we often say things like NOAA predicts that the solar flux index is likely to decrease over the next 7 days, and in fact it goes up. So I'll make my apologies. No, that's all we can work from. That's all we've got in terms of forecast. I think hopefully the forecast will get a bit better, but I sometimes find that as I said, the United States Air Force one is more accurate than the NOAA one. But as I said, I spoke to the Met Office about this and said, look, do you have any figures? And they said, well, no, to be honest, that's where we get our figures from, but we only go forward 4 days. We can't predict any further than that. So I need 4 days would take me to, say, Monday from Thursday. But then we've got the rest of the week as well. So by the time you hear it on Sunday on GB2RS, as I said, it's already 4 days old, that prediction. So I'm a bit wary of it. It's very hard to predict what's going to happen. You can talk generally about what's going to happen with the sun, and we know what's going to happen with the sun because it's quite active at the moment. So we can predict that there will be solar flares, there will be coronal mass ejections, that the solar flux index will stay high, but actually coming up with numbers that are going to be accurate in that length of time is very, very hard indeed. So there you go. That's my excuse anyway, but that's why it's a problem. And this is the solar wind measurement on solarham.net. It's probably maybe a little bit hard for you to see because the colors aren't terribly good. But you can see the top line there, the red one on the top line is a measure of the BZ. And you can see it either goes positive or negative. It goes north or it goes south. And it can do that quite regularly, quite erratically. The next one down is density. Well, that shows you that the material coming off the sun changes, the density of it changes. And then the speed, it's the middle line is 500 kilometers per second, and you'll see there's a spike there up to about 600 kilometers a second. Then it goes down to about 400. What I'm trying to say is this isn't a static system. It's constantly changing. And we don't quite know what we're going to get in terms of density, in terms of speed, in terms of BZ. So I think you could probably do a pretty good prediction, maybe 1 day ahead or half a day ahead or 1 hour ahead using just this information. But trying to do it for a week is really, really tough. So let's get to talk about this interplanetary magnetic field, or BZ, again, just to show you. So you can see that this is a model of the Earth and Sun environment. And you can see that the solar wind coming off the Sun actually kind of distorts the Earth's magnetic field. So it causes this magneto tail to appear. This should be like a nice polar plot, if you like, of the Earth's magnetic field. But it doesn't. It pushes it out. And what happens is that the plasma coming in off the solar wind can go around the Earth and meet at that neutral point, at which point you get something called magnetic recombination, and it flies back, and that's what causes the aurora. So that's not good at all. So this distortion of the Earth's magnetic field is what drives the K index, but I thought it'd be nice to just show a diagram of how it's actually affecting it. So, as I said, the sun's magnetic field isn't confined to the immediate area of our star. It carries it throughout the solar system. I think the sun's magnetic field and plasma goes right out as far as Pluto. It really does. The Earth's magnetic field, obviously pointing north, and the IMF come into contact at the magnetopause. And if it's pointing south, we call that a southward BZ. That's a southward pointing B field. Then the interplanetary magnetic field can partially cancel the Earth's magnetic field at that point of contact, and that allows a window to be opened, if you like, a door to be opened from the solar wind that can reach the Earth's atmosphere, and that's when we get aurora. And so what you need to look for if you want to see aurora is a southward BZ, a southward pointing BZ, and a high K index. So if you see a high K index and you look at solarham.net and the BZ is pointing south, then that's going to probably be a widespread aurora. In terms of geomagnetic storms, which is what we call it when we get this plasma coming off the sun and it affects the Earth, this is a graph of geomagnetic storms from 1994 to 2016. And it just shows you the variation. Generally, we get geomagnetic storms on the downward side of the solar cycle. We've had quite a lot recently, actually, but this shows that it's actually worse just after solar maximum, so we've got more to come. But then if we get to solar minimum, we can go long periods of time without a solar wind at all, or not so much as without a solar wind, but don't get that many geomagnetic storms. So I think I gave a talk to the RSGB convention a couple of years ago, and I said the space weather, the good, the bad, the downright ugly. And this is one of the ugly things of it. You know, solar flares and geomagnetic storms go with the territory, I'm afraid. If you want sunspots, you're going to get these as well. So don't be surprised. We do have a number of days when things are not good at all. We had a situation last week where both the Chiltern ionosonde and the Fairford ionosonde were not recording where the F2 layer was at all. There was just nothing to see, and that was due, I think, to a geomagnetic storm. And so that just shows you that it stopped the the ionosphere, the F2 layer, being seen by the digisondes because the geomagnetic storming was just so bad. And this is a graph from Chiltern, the Chiltern digisonde, and I don't want to go into too much detail because some people find these hard to read. But if you want, I can just talk you through what they show. Basically, a digisonde is something that fires a radio wave straight up into the ionosphere and measures what comes back down. And you can see this trace. You'll see the bottom trace there, or the one in the middle shows you the red line and the green line. That shows you that the reflection stops coming back off the ionosphere about 400 kilometers. So that's F2 layer. And it's just over 7 megahertz at that point. You'll also notice two things. That one, we've got a green trace and we've got a red trace. This is because any radio wave going through the ionosphere gets broken into two waves. It gets split up, and we end up with what is known as an ordinary wave and an extraordinary wave. So the red plot is the ordinary wave, and the green plot is the extraordinary wave. And you'll notice that the extraordinary wave's critical frequency is a little bit higher. So when we talk about critical frequency, we need to know what we're talking about. And usually we talk about the ordinary wave. But you can see there it's just about 7.4 megahertz. So anything above 7.4 megahertz goes straight up, out past the ionosphere and into space. Another thing I'll just point out here is you'll see there's another trace there at 550 kilometers high. And this is in fact a second reflection. So we've got the signal, radio signal going from the Earth to the ionosphere and then coming back down again. Then it bounces off the Earth and goes back up again. So you often get, and do get, with Digison details, two traces like this. And the second one is always, you know, one double the height of the first one, but we kind of have to ignore that. So this is a raw Digison plot, and they're not too easy to read. But we can derive things from this. If you look down the bottom where it says D and then MUF, this says that over a 3,000 kilometer path, the maximum usable frequency was going to be about 25.4 megahertz. This has been extrapolated from this data. We know that the critical frequency here was just over 7 megahertz, 7.3, and we call that the FO-F2, critical frequency FO of the F2 layer. And you'll see that on the top there, it says 7.3 at the top left of the chart. And so we can, from that, we can deduce that over 100 kilometers, it would be 7.9 megahertz would be the maximum usable frequency, or 25 megahertz over 3,000 kilometers. So from this, you can quickly do some calculations in terms of what's what. But these charts are not easy to read. You can get them from Chiltern every day. They're usually updated every, I think it's 15 minutes. But Jim Bacon, bless him, took the information and said, right, well, I think we can make this a bit easier to read. And that's where this is the basis of PropQuest. And this is a chart that is produced automatically. And it gives us the options of selecting the Fairford Digison, the Chiltern Digison, or the Daub Digison. And it shows you the critical frequency and maximum usable frequency over different path lengths for every hour of the day. So you can see there that as the sun rises, the maximum usable frequency goes up. Well, that makes sense. And then roughly peaks around midday and then goes back down again. At the moment, it's peaking above about 30 megahertz because of the amount of solar activity. But this is a really good way of deciding what bands you're going to work on. You can have a look at this and see, right, okay, well, it looks like 10 meters is open, 28 megs is open. It also shows you what we call FOF2, which is the critical frequency, i.e. 6.75 megahertz. And that suggests there that over 100 kilometers, then the maximum usable frequency about 7.38, 7.4 megahertz. So there are times, especially overnight, when 7 megs won't get you very far. You might be able to work into Europe, but you can't work around the UK. And this is why, because the skip length to work around the UK, you've got a much, much higher angle signal having to go up and come down again. And it's just too much for the frequency that you're using. And in fact, the signal is just going straight up and carry on into space. But lower angle signals can travel and get refracted easier. So it's quite easy at night where you maybe not be able to hear somebody about 25, 30 miles away, but you could talk to somebody in Germany. And I think people find that a bit confusing, but this is why. This is what a way of explaining the skip distance and the critical frequency to show you what is going on. Now, with PropQuest, you can click on these and switch them on and off. So if you go along the bottom on PropQuest and just click on where it says, on one of these, you can turn these on or off. So that'll be good. And over the next, from May onwards, it'll also show us the FOEs. So that's the critical frequency of the sporadic E layer. And so we'll see that one coming up. And then you may see that some of these higher frequency predictions disappear because it means that the E layer is refracting everything. And so it's not getting up to the F layer. The other thing I can say is that we do know that this summer or winter is completely different. The ionosphere, the characteristics of the ionosphere change in the summer. So what you fundamentally find is the maximum usable frequencies go down in the summer during the day. And so if you have been working lots and lots of stateside stuff in maybe November to March, don't be surprised if come June you can't do that at 28 megs. Because, as I said, the ionospheric chemistry changes. Basically, what you do in the summer, you get more diatomic molecules, and they are much, much harder to ionize than monatomic elements and species. So this is why the conditions in the summer are not so good for DX, but then come September again, it all starts to dissociate, and we get much, much higher frequencies. So it always seems odd to me that you think, well, if the ionosphere is supposed to be affected by the sun, how come it's not better in the summer? Well, that's why. It's partly due to heating effects in the ionosphere, and partly due to, as I said, the diatomic molecule situation. But there we go. That's PropQuest. So if you've never played with PropQuest, please do. So it will teach you a lot. It will show you sometimes why you can't work around the UK on 7 megahertz, say. And it will also show you why you can work around the world on 28 megahertz if the MUF is high enough. So let's put it all together then. This is from a VK3. So what do we need? We need a high solar flux index. So good conditions are maybe in excess of 200. Actually, anything more than 100 is going to open up 10 meters, but anything more than 150 or 180 is going to be better. If you're getting solar flux indices of 200 to 300, you're having a laugh. You really are. It's going to be brilliant. So the solar flux index has to be above maybe 100, 150 for a few consecutive days. It kind of gives a chance for the ionosphere to build up. But at the same time, we want the K index to be lower. Lower the better. So if you have a high solar flux index and a low K index, that's as good as it gets. You've got brilliant conditions. You've got no absorption, high maximum usable frequency, and everything works a treat. If you have the reverse effect, so if you have a low solar flux index and a high K index, then that's not good at all. But so that's what you need to know. You need to know that you need a high solar flux index, and you need to keep the K index low. So we mustn't have disturbed conditions. Now I'm just briefly going to talk, if we've got time, to talk about RADCOM. Now there's a chart in RADCOM that appears every month called the HF F-layer propagation predictions. And there's a limit to what you can do in a publication, because this is all based on 100 watts to a dipole. But if you have got a better or worse situation, we've made it now so that you can go to VOACAP, so voacap.com/radcom. You can now put in how much power you're running, what mode you're running, what your antennas are at both ends of the pass, and you get a set of charts that look like this. So they're kind of based on the same things that you're seeing on RADCOM, but they're more specific to your particular situation. So if you've got a 4-element Yagi at 300 feet, good luck with it. But if you're running maximum power, which is obviously 400 watts, if you've got the license for it, and you can plug all these figures into this and produce a set of charts that you can print off and put on the wall. We couldn't do this in RADCOM. We've talked about this over and over again, and there isn't enough space to do it. So we thought the best thing to do is actually make it as a facility, an online facility on the internet. So that's VOACAP. Where are we? VOACAP.com/radcom. We'll get you the VOACAP ones, and that'll give you some colorful charts like this. And you can do other prediction charts like this. This is from the UK to New York, and it gives you a rosette type picture that shows you the best optimum band at a particular time. So looking at that, if you look at maybe 4 o'clock when this was produced, you can see that the best band for that was 20 meters on that particular day. And now there's another, that's using VOACAP. There's another program called ITU-RHF prop, which is a real mouthful, I know. But basically, we have the ability to produce these predictions using ITU-RHF prop as well. So that's soundbites.asia/proppy/radcom. And again, you can put in the power, your mode, what antenna you've got in terms of gain at both ends, and print off. And the thing is that these are exactly the same locations as are in Radcom. So you can produce yourself a personalized set of instructions or predictions for your station setup in terms of power, mode, and gain. And this is a propagation chart, area chart that shows in Proppy, just to show you that some of the facilities are available. So those URLs, make a note of them: soundbites.asia/Proppy and vocap.com/radcom. But I mean, five or 6 years ago, we were all trying to use PC-based prediction programs, and it's all gone online now, so it's free. And there's point-to-point propagation prediction there on Proppy. Again, you put in the time, power, mode, your noise level, whether you want short path, long path, and latitude and longitude. And again, it will produce something like that, which shows you like a heat map of the best time to work places. I use this extensively. I used this when I was trying to do my Work Tall States Award, because I wanted to work Wyoming, and it showed you that the best time was, I think it's 4 o'clock in the afternoon, and it worked a treat. It's better than just going on the air and trying to just work anything. You know, if you want to work a specific area, this is the best way to work out the best time to do it. Right, so that's the presentation. Just a reminder that there are 2 YouTube presentations available: Understanding HF Propagation, which looks at a lot of what I've talked about tonight, and Understanding VHF Propagation as well, which looks at VHF, auroral modes, rain scatter, all sorts of things in there. And they're freely available on YouTube. They're getting a little bit old now, but the propagation doesn't really change. The science doesn't change. But there we go. And this presentation is available at G0KYA.blogspot.co.uk. And I wanted to time this to end at 9, and it's 8:58 and a few seconds, so we've done right. So there we go, David. That's it for tonight, anyway.
Lovely, Steve. Thank you very much indeed. Well, before I get to some of your questions, I've only got one at the moment. This is the time to ask your questions or make comments or anything for Steve, and we'll certainly relay them to him in a moment. Steve, before we move to Roger's question that's there, can I just ask you, you just said that the science hasn't changed, but often as life progresses, you know, we learn more about things. So although the science may not have changed, and the videos that you've done years ago, I presume the tools and things like PropQuest and other things like that have improved the way that we understand those figures and things like that.
Yeah, I mean, the programs that are available now online, like vocap.com and ITR, HF Prop or Proppy, are available now online. So the prediction tools have changed dramatically, and it's much easier to make predictions now. And you don't have to have a fantastic computer to do it, because you can use just a tablet and go online and do that. So the tools have changed dramatically. And the amount of information that we can get in terms of solar flux index, K index, solar wind speed and everything, that has changed. But the physics, I think, of propagation they haven't changed that much. We had to make some changes when FT8 came along, because it could hear down into the noise, and nobody had ever done it before. And I sat with Carl K9LA at an RSGB convention. We sort of tried to thrash out how were we going to do that, and he went away and came up with some details of, you know, we knew that FT8 could hear down into the noise. So we thought, well, if we change the noise figure on these prediction programs, does it come up with anything? Well, yes, it did. So that was a help. So yeah, so the physics of propagation don't appear to have changed, but the way we're using propagation now, in terms of the modes, in terms of the antenna gain, there's not been that many changes. I mean, yeah, Scott McIntosh has come up with a theory about how the sun may develop. we'll have to see whether he was right or not, because he was predicting an astronomical, no pun intended, solar event this solar cycle, and it's not beginning to appear to be too accurate at the moment. It looks like this solar cycle will be similar to the last one at the moment. I mean, we've still got a couple of years or 3 years to go. So yes, there are theories, but I don't think there's been anything terribly new. Really, I mean, most of the books we read, and the information we use about HF propagation is all written in the 60s and 70s, and I don't think that much has changed. So what has changed are the tools available, and also, yes, we used to work with CW, Morse, and sideband. Now we're talking about FT8, JT65, and everything else, FT4, that can hear much, much further down into the noise. So, but we can adapt the programs to take that into effect. And in fact, it has happened. I did some sums, and eventually we went to Joe Taylor and said, look, this is what we think. What do you think? And I think we were within about a dB of what he'd said. So yeah, that was an easy win. Once Carl had done the hard work on working out what we needed to do. But yeah, I can remember the conversation distinctly. We went a few years back talking to Carl Canine LA over a beer and going, how are we going to do this then? And he went away and thought about it and came up with some theories, and then we tested them and came up with it. So yeah.
Thank you. Yeah,
but, yeah, I'd love to think that things are changing and science is changing, but fundamentally we know how radio waves get from A to B, and we can predict what will happen. What we're not terribly good at doing is predicting what the sun's going to do within the next month. We can probably do it within about a day or half a day, but we're not very good at predicting what it's going to do over a longer term.
Thanks.
I wish we could.
Yeah,
as I said, every week I use the solar flux index from NOAA, and every week they're wrong.
Oh, and without wishing to, and I will get to your questions at home now, but without wishing to diss in any way what the Radcom publish, obviously Radcom, with the lead times of publishing print, you're looking at maybe 2 months, or certainly a month at the very least between them. So I guess from one point in your presentation, you said really you can't see much further ahead from just a few days, and sometimes indeed your forecast that I think you upload on a Thursday, by the time it's read on the GB2RS News on a Sunday, it's already, 3 days, 4 days old. Yeah.
Yeah, well, Radcom works on the smooth sunspot number. Basically, we take an average over the period. It's called a 12-month smooth sunspot number, and they're based on these average figures, which are, on the whole, more accurate than the daily figure. The daily figure can be a bit misleading, so we take a smooth average, and that gives us what we're known as median figures for the month. So we can say that some days will be better than this, and some days will be worse. But the median figure for the maximum usable frequency, or the distances you want to work, is probably a better option to take. So that's where those figures come from.
Thank you. Right, to your questions at home now. First from Roger G3LDI. WCY only gives the KP as a single figure. Are those forecasts with decimal places on SolarHam?
SolarHam have got them reported. If we talk about predictions, they're usually just round numbers. But if you talk about the actual K index, that I think on solarham.com they are to 1 decimal place. So yeah, but I've been seeing figures like 3.8, 4.4, and whatever recently. But they only just started doing that. So I'm not surprised that some places are still doing predictions, maybe to the nearest whole number. But yeah, the actual physical reported K index generally is reported to 1 decimal figure now.
And I guess that's important if you're trying to see maybe a trend, whether something's going up or down. That's quite important then, rather than just see the integer amount.
Well, yeah, because if the K index is 4.9, it's going to be a hell of a lot worse than 4.1. But so it is better and it's more accurate, I think, to think of it in terms of a decimal point.
Okay, yeah. I hope that helps you, Roger. Now from Malcolm G3PDH, we used to refer to solar flare fade-outs as Dellinger fade-out. Was that the scientist who discovered it?
I think it was. I think it was. I don't know if he discovered it, but certainly Dellinger fade outs were what they were known as, or shortwave fade outs. There's another term, yeah, Dellinger. I can't remember. I'd have to look it up. But yeah, that is what we're talking about.
Okay.
And if you've never heard one, you'll probably know it. But so the only way you really come across these things is be on the air for a long period of time. It's just like somebody flicking a switch.
Yeah, I've heard people say it. Don't think I've experienced that myself. Maybe when we were running a special event a few months ago, I certainly thought, is my equipment all right? And suddenly the reception and everything was very different. But yeah, it certainly helps to, and as I said to you at the beginning, I mean, for most of us who read or listen to the GB2RS news in your forecast, indeed the one we publish on the NARC website as well, it does help to make more sense of those numbers, because saying KP index went out and the MUFs go down or up, and it doesn't always make sense. So this has been really good, Steve.
No, just to give you an idea, when I took over writing that a few years ago, I banned the term BZ and banned the, what else did I ban? I banned the solar wind speed, unless I could actually say, oh, and the BZ is heading south, which means it is more likely to impact the Earth. So, because we just used to put these figures out, and I just said, well, is that good or bad? I mean, that's the thing. If you don't know, then it's meaningless. So we try to introduce terms into GB2RS that actually help people.
Yeah, absolutely.
So
in fact, one of the questions I was going to ask you as well was, when you talked about solar flares and CMEs and things affecting the world, would it affect the whole world, or would it just be the part that was facing the sun at the time, and given how quickly these things can change?
Solar flares affect the side of the Earth that's facing the sun. So you are getting a shortwave fade out or Dellinger fade out would be the sun side of the Earth. As for everything else, because of the way it works, these particles get funneled into the poles, effectively, because of the Earth's magnetic field. So it can affect the whole world. First thing you notice is that you lose polar paths, or they become very noisy and disturbed. So I was listening the other day to a station from Seattle, I think, and it was very hard to make out what he was saying. And Morse is very hard to decode as well, because it gets very fluttery. And auroral flutter is the term we use. And if it's a really serious CME event or something, the effects come down in terms of latitude. So this is why, when it's a really bad CME hits and the K index goes up, you can start to see aurora from the UK. I mean, I think it was visible from Cornwall or Somerset, the last one we had. So yeah, and it affects the whole world because it's pouring into the poles. But we measure this KP index in a number of places around the world, and you can see that it has the worst effect up at, say, Alaska. One of the magnetometers at Fairbanks, Alaska, I think, and that's always worse. And the Norwegian ones are worse than ones on the equator. Ones on the equator probably don't measure much at all, because it affects the northern and southern hemisphere, the poles much worse than it does the equator. But half the time our signals, if our signals have to go from here to the States, say the west coast of the States, they are passing probably through the auroral oval. So we know that high K index is not good for those sorts of paths.
Yeah.
If that helps.
It's such a subject, isn't it? I'm amazed at how much you know about it. It's incredible. Another over on BATC, a question from Jim G0KYA. Great presentation, Steve. What can the difference in KP to local K index be? And presumably we should use local K for things like E's. Not sure of the value of the decimal value, though, of the average KP, though.
Yeah. Right, local K index. That's a good question. I think if you're talking about sporadic E, I'd have to have a long discussion with Jim about this. It probably is better to know what the local K index is at your latitude or your location. But you need to have your own magnetometer to do that. Now in the States, they're working on a project where people can put their own magnetometers in and measure actually, we've got one of our PSC members has done some work on this. So you could actually work out the K index for your locality by using a magnetometer in the back garden, say. The only problem with that is if you run over it with a lawnmower, it will go off the scale because it thinks it's had a massive CME hit it. But there we go. So that's the first one. So do we need to know the local K index? Yes, I guess we do. And I think that the closest to us would be Lancaster University, I think, published their details. But and as for the decimal point on the K index, it depends what you're doing. I think if you're a scientist and you're trying to do precise work, then knowing the K index to a decimal point is probably worthwhile. And as I said, I think that a K index of 4.9 has more effect on HF than 4.1. But if you don't have that decimal point, you never know that it was there. I don't know. It's early days, I think, for the decimal K indices, as it were. I don't know if that answers Jim's question or not, actually.
I'm sure he'll tell us if it hasn't. I know you two correspond a lot anyway, of course.
Yeah.
And Roger G0KYA adds a note that he says, we heard a Dellinger happen on NFD once when we were at DIS. A very strange experience, he says.
Yeah, as I said, the only way you're going to spot these things, unless you're very, very lucky, is you go on a special event station or field day station or something, and you're operating for 24 hours or something. Well, in daylight anyway, so 6 or 7 hours, and you actually see the damn thing disappear. But yeah, I've heard it described as somebody just flicking a switch and turning the ionosphere off. And that's basically what happens. It comes back over, 20, 30 minutes. But we're going to get a lot more of these before we get to solar maximum. And they do say that on average, the geomagnetic events are more prevalent on the downward side of the cycle. So it's not only on when we're going up, but coming down, we get geomagnetic disturbances as well.
Yeah. I don't want to be a doom-monger here in any way, but I was just thinking that things like climate change, we're always hearing about the increase in climate change. I don't want to say, really don't want to be a doom-monger, but is there any evidence? Some of the things that you suggested could be quite frightening for the Earth. Is there any suggestion that these things are getting worse? Or is it just that part of this cycle 25 that we're in at the moment, and is it just a cycle that will again fade out again?
Well, in some respects, it's what we call the Daily Mail effect. Every month or so, you'll see a story in the Daily Mail that says, "Oh, we're doom and gloom. We're going to be hit by a massive coronal mass ejection. We're all going to die," and you don't notice any difference. I mean, I'm trying to remember what this film was I saw. I think it was called Numbers. Yeah, that's right. And basically, it's a massive coronal mass ejection that hits the Earth and wipes the atmosphere off the Earth. Is that likely to happen? Hope not. But yeah, I think it is a problem, but it's a problem that people make out to be bigger than it is. There's always doom and gloom talks about what would happen to the world if we got hit with a massive CME. And when we had the Carrington event back in the, late 1800s, it had a serious effect. I mean, it's all sorts of things happen. You get electrical transformers can burn out, not due to the induced current so much in the transformer, but because they operate over long distances. Sort of in Cornwall, if you think about, you've got transformers, but they're connected and over like 100 miles or so. So you get differential currents or differential voltages over that 100, and that's that sort of thing that can burn the transformer out. So it is a problem, and it is something that the government has looked at and have white papers on, and I know it's on the risk register. But exactly how bad it would be and when is it going to happen, that's a tricky one. I don't think anybody really likes to talk about it. If you talk to any satellite operator about the problems they have with CMEs and whatever, they go quiet, because that would affect their share price. I know this when I was working for Inmarsat. Yeah, it's interesting, and nobody really knows, because we now have more technology, more computers, more telephone exchanges and telephone wires and everything now than any other time in the past. So we'll have to wait and see. The good news is we're using more fiber optics that aren't affected by CMEs. But yeah, we'll have to see. I mean, Quebec, 1987, I think they had problems. But again, that's an area that is massive and with very, very long electrical wires, and it causes problems. You get induced currents. I think they're called GICs, GICs, ground-induced currents, when you get the CMEs. And yes, it caused massive issues, but we'll have to wait and see. Are things getting worse? It's really hard to say because we haven't had the means to monitor this stuff that long, really, if you think about it. And K-index has probably been measured since, I don't know, the war or thereabouts. But we've got more and more monitoring taking place now. So will we get a major Carrington event, and what effect will it have on the Earth? I don't know. I don't think anybody else does either.
By the way, Andy M0NKR has come back and said that he thinks the film you're thinking about is Solar Attack.
Oh, not heard that one. Must be a similar one.
Another one. All right. Thank you. Yeah. Just a couple of final comments for you. Malcolm G3PDH says, a big CME caused big problems on Canadian Power Network a few years ago.
1987, Quebec, yeah.
Right, that was the one, I guess. Okay.
That was the one, yeah.
And finally then, Jim just coming back, Jim G0KYA, was thinking of the fact that it was an average, so knowing an average to many decimal points may not be as useful as a good local value, possibly, he says.
Possibly, yeah. Yeah, I think that's a discussion over a beer, I think. But
that's
yes,
an offer for you, Jim.
There is. Well, how can I put it? Americans in America, there's an organisation called HAM-Sci, which is the Ham Science Group, and they were developing magnetometers for hams to put in their back garden. And we've got our name down to buy one of these when they were released, but it's been delayed by a couple of years at least. But yeah, as I said, I know that they had problems. I think it was University of Lancaster, because they got this massive reading of a CME and couldn't work out why, because they were the only one that got it, and it was caused by a gardener going over the magnetometer with his lawnmower.
Oh,
so yeah, it's not the be all and end all if you've got a magnetometer in the back garden.
Not at all. Right. Well, Steve, thank you ever so much for this evening. You really have helped untangle those numbers and help us all understand those propagation forecasts that you and your team bring us every week. We're really, honestly, very fortunate as well to have you amongst our members of NARC and to give us a personal presentation like this. So thanks once again for what you do for us as a club and also for the amateur radio hobby as a whole. Thank you.
No problem at all. It's my pleasure.
Thank you, Steve. There we are. Now we know all about it. And it does, I'm sure it will make us all understand a little bit better the propagation forecasts and things, as I said, that we read and we hear about every week. So thanks very much to Steve, G0KYA. Before we go, just a quick reminder of what's happening at the club this week. Sunday, the GB2RS news at 7 o'clock or GB3MB. Monday night, also on GB3MB, the Monday night net at 7:30. At 8 o'clock, the CW net on 3.543 megahertz. And then, as I said, next Wednesday, we won't be meeting here online. We'll be in person at CNS, where we've got those first sessions of the NARC Maker Construction Group and the NARC Raspberry Pi Jam. And don't forget the Shandies as well that we've got. And the following Wednesday after that is, of course, our AGM. So please vote. I mean, tonight we had an average, I was looking earlier, about 63 people watching this live, and then 30 odd people or so watch the recording in the next few days. So please, if you haven't done so already, please vote for your favourite talk of last year, because it's only right that we celebrate those people who give their time, just like Steve has tonight, and give us such wonderful, entertaining and educational talks as we do. But that's it for NARC. We look forward to hearing your stories, your pictures and your videos as well. But for now, from Tammy M0TC.
Bye-bye.
And from me, David G7RP. Good night. Take care of yourselves. Bye-bye.